Hi, Assalamualaikum and a very good morning. So today we're going to do past year question for SK025, which is the chemistry matriculation program for the past year question, focusing on the year of 2019 and 2020. So before we go straight into the question, let us look into what is the provided in the question booklet. So as what you know that during the exam, there will be no formula will be provided in the exam. What is provided to you is that you're going to be provided with the table of the relative atomic masses, where you will be given the list of the element here, and then you will be given the atomic number as well as the relative atomic masses. So atomic number here refers to the proton number, and the relative atomic mass refers to the molar mass. Okay, so you need to be very careful because some of you might do the mistake of finding the molar mass. For example, the aluminium, the molar mass supposed to be 27, not 13. Okay, so 13 ni adalah proton number, 27 adalah molar mass. So kena berhati-hati. Okay, and on the next part here, this shows that this is a list of constant, and in the semester 2, what is important that you need to know is the molar of the gases constant here, which refers to R. So here you will be given the value of R to be 8.314 joule per Kelvin per mole. Okay. Also, you need to know the specific heat of water, where it refers to 4.18 joule per gram per Kelvin or per degree Celsius. And then the next part that you need to know is the 1 Faraday, which refers to 96,500 coulomb. Okay, so the specific heat of water is popular in the chapter of Thermochemistry. And then for the molar of gases constant R, it is popular in the chapter 1, which is reaction kinetics, where you will be using R specifically in the Arrhenius equation. Meanwhile, for the Faraday, which refers to 96,500 coulomb, you will be dealing with this in the chapter of electrochemistry. Okay, so some of the information that you are required is given in the booklet. So you can always refer back at the front, and these are the three important ones in my opinion. Okay, so by understanding this, let us go straight to the question. So for question number 1, the data for the reaction between the methyl ethanoate CH3COOCH3 with hydroxide OH- at certain temperature is as shown in table 1. So here are the results. And then for question 1A1, we have to determine the order of the reaction with respect to each reactant. Okay, so nak cari order of reaction, mula-mula sekali we need to do the rate law. So rate is equal to K, which is the rate constant, and then kita letak kita punya concentration of the reactant, which is the CH3 COOCH3, and then order of the reaction, we need to write an unknown M here. Okay, so M is the unknown, and then you need to continue with OH-, which is another reactant, where the order of the reaction is the unknown N. Okay, so that is the first step. Okay, selepas dapat rate law, what we're going to need to do is we need to find we need to compare the experiment between what's given here in the data. Okay, so in order for us to do that, we need to compare to experiment. Okay, for example, if I want to find the value of N, okay, value of N, I need to compare experiment 2 and experiment 1 here. Okay, so here and here is the same, so I can compare this one in this one. Okay, so what I'm going to do is I'm going to compare experiment 2 divided by experiment 1. Okay, So for my experiment 2, the rate going to be 2.013 times 10 to the power of negative 3. Okay, berhati-hati, times 10 to the power of negative 3 mesti include. And then for experiment 1, I'm going to have 1.58. Okay, and then the K is still the same, and my concentration of the methyl ethanoate for experiment number 2 going to be 0.050. So it's going to be 0.050. Okay, and then for OH minus it's going to be 0.154 to the power of n. Okay, untuk eksperimen 1 tadi rate dia adalah 1.58, methyl ethanoate dia adalah 0.050, and then dia punya hydroxide adalah 0.120. Okay, so lepas kita compare, what we're going to do is we need to cut off what is similar term. Okay, as what you can see here, the K and K going to be the same, so we can cancel it out. 0.050 to the power of m can be cancelled out with the downwards. So what's left is this term here and the other term here. Okay, so 2.03 times 10 to the power of negative 3 divided by 1.58 times 10 to the power of negative 3. Bila tekan calculator, what you're going to get is 1.28. Okay, 0.14 divided n divided by 0.120 n, what you're going to get is 1.28 to the power of n. Okay, so your base is going to be 1.28 to the power of 1 is equal to 1.28 to the power of n. Therefore, we can say that n is equal to 1. Okay, and we need to do the conclusion. So we can say that the order of the reaction with respect to OH minus, pasal N adalah refer kepada OH minus, is a first order reaction. Okay, so kita dah dapat cari N. Now we need to find M. Okay, we need to find M. So in order to find M, we need to find the concentration of M that is changing. So as what you can see, we can compare number 3 with number 2. Because 0.154 can be cancelled out, and then we can compare here again with this value here. Okay, so what I'm going to do is I'm going to compare experiment 3 divided by experiment 2. Okay, so let's say my experiment 3 here will have the rate of 3.40 times 10 to the power of negative 3. Okay, that times 10 to the power of negative 3 jangan tinggal. Okay, because the substitution need to be correct. And then I'm going to divide it with 2.03. Okay, ini datang pada eksperimen 3. And then my concentration of methyl ethanoate is going to be 0.084, which is here. And then my concentration of hydroxide going to be 0.154 to the power of n. Okay, and for experiment 2, it's going to be the yellow color, which is 2.03, and then 0.050, and then 0.154. Okay, so the yellow color here, then the green color here. Okay, so now, as usual, we need to find the similar term. So as what you can see here, K and K can be cancelled out, and 0.154 n and 0.154 n can be cancelled out. So 3.4 times 10 to the power of negative 3 divided by 2.03 times 10 to the power of negative 3, what you're going to get is 1.67. And if you divide 0.084 divided by 0.050, what you're going to get is 1.68. So it almost very close by to each other. So similarly, you can say that 1.68 to the power of 1 is the same as 1.68 to the power of m. So m is equal to 1. Okay. Jadi kita boleh buat conclusion where we can say that therefore the order of the reaction with respect of CH3COOCH3, which is the methyl ethanoate, M is a first order reaction. Okay, so yang conclusion tadi adalah penting. Okay, now once we do that, we can answer question A2 where we have to write the red law for the reaction. Okay, so our red law is rate is equal to K methyl ethanate to the power of M, hydroxide to the power of N. Okay, cuma tadi kita dah dapat dah M equal to 1, N pun equal to 1. So we just substitute back M equal to 1 here and N equal to 1 here. So what you can say is that rate is equal to K methyl ethanate to the power of 1 and then hydroxide to the power of 1. Okay, nak tunjuk satu-satu pun tak jadi masalah. Nak tinggalkan, tak nak tulis pun tak jadi masalah because it's still 1 and 1. Okay, so settle for A2. Now we need to calculate the rate constant. So in order to calculate the rate constant, we need to use our rate law again. Okay, so in order to find the rate constant, our rate constant is K. Okay, rate constant tadi refer kepada K. Okay, so kita boleh pilih mana-mana eksperimen, but for this case, I'm going to use from experiment number 1. So from experiment number 1, the initial rate going to be 1.58 times 10 to the power of negative 3 molar per second. And then I need to find my K. And then the concentration of the methyl ethanate going to be 0.050. And then my concentration of hydroxide going to be 0.12. Okay, so I can divide my 0.050 to this side and 0.120 into the other side. So at the end, I'm going to get my K is equal to 0.2633 per mole per second. Okay, so ensure that your unit is correct. Okay, pasal kamu tahu kamu punya rate adalah molar per second. And then kamu divide dengan molar dan molar. So it's going to be molar times molar. So the overall unit going to be M minus 1 second minus 1. Okay, pasal ini seolah-olah M kuasa 2. Okay. And now, we need to do question A4. How many times will the rate increase if the concentration of both the methyl ethanate and hydroxide are double? So, if we have our rate equal to K methyl concentration of methyl ethanate and hydroxide, kalau concentration kita 1 dan 1, kita akan dapat K lah. Okay, kalau kita bayang sini 1 dan sini 1. Tapi sekarang, if we double both of the concentrations, so it's going to be 2 here and also 2 here. Okay, so if I were to do that, I will get my rate is equal to K times 2 times 2. So it's going to be 4K. Okay, so the difference between the first equation and the second equation is it is multiplied by 4. Okay, so I can say that the rate of the reaction will increase by 4 times. Okay, so that is how to answer question number 1A. So now for question 1B, the decomposition of ammonia to nitrogen gas and hydrogen at 450 degrees Celsius was studied on the surface of tungsten and osmium catalyst. The profile diagram for the reaction using each catalyst is given in the figure 1 here. Okay, so in this question, B1, we have to identify which catalyst is better for this reaction, and we have to provide explanation. So as what you can see on the energy profile diagram here, the tungsten will have a lower activation energy in comparison to osmium. So you're going to say that the tungsten will be the better catalyst. Okay, this is because the tungsten will provide an alternative pathway with a lower activation energy in comparison to osmium. So this will causes more ammonia molecule will having a activation energy will have a kinetic energy equal or greater to the activation energy. Hence, this will increase the frequency of collision, and as a result, the frequency of effective collision will also increase. Thus, the rate of the reaction will also increases. Okay, and now for question B2, the activation energy for the above reaction using tungsten is 163 kilojoule per mole. So our activation energy here, which is EA, is 163 kilojoule per mole. And then we need to find how many times faster is the reaction if the temperature is increased to 550 degrees Celsius. Okay, so we can say that the rate of the reaction of K1 is unknown if the temperature is 550 degrees Celsius. So in order to understand more about the Arrhenius equation, we need to convert the temperature into Kelvin. Okay, so we need to add up with 273.15, and then 550 plus 273, we're gonna get 823.15. Okay, if the temperature is at 450, which is original temperature here, 450, our K2 here is don't know also. Okay, kita pun tidak tahu. Okay, tetapi temperature kita masih kena ubah dalam bentuk Kelvin. So we're gonna get 723.15. Okay, so maksud soalan, which is how many times faster, adalah kita kena compare dan cari ratio antara K1 divided by K2. Okay, so bila temperature dinaikkan ke 823.15 Kelvin, berapa lajukah K1 berbanding K2? So we need to find the ratio. Okay, so in this case, which involve two temperature, we're going to use the Arrhenius equation of ln K1 over K2 equal to EA over R 1 over T2 minus 1 over T1. Okay, dekat sini kena berhati-hati. So K1 ended with T1. Jangan terbalik. Okay, so what we're going to find in this equation here is K1 over K2. Okay, so ln K1 over K2 is basically equal to the activation energy is given as 163. K ni jangan lupa because K refers to times 10 to the power of 3. Okay, and then our R here refers to gas constant. So you can know the idea or the value of gas constant is from the list of constant that I've shown in the earlier video. Okay, in the earlier part of the video. So the gas constant here will refers to 8.314 joule per Kelvin per mole. So you can get that in the list of constant. Okay, so your activation energy is 163 times 10 to the power of 3. So this one, jangan lupa expand, joule per mole, and then divided by 8.314. So per mole and per mole can cancel out, joule and joule can cancel out. And then you need to multiply that by using a temperature. So T2 here refers to 723.15. So multiply by 1 over 723.15 Kelvin minus 1 over 83.15 Kelvin. So the whole term bracket here will have the unit of Kelvin. So Kelvin and per Kelvin can be cancelled out. So they're going to be no unit. So 163 times 10 to the power of 3 divided by 8.314 multiplied by the term here, what you're going to get is ln K1 over K2 is equal to 3.294. Okay, and then you need to find K1 over K2, right? So you need to bring the ln on the right hand side. So it's going to be e to the power of 3.294, and then what you're going to get is 26.94. Okay, so K1 over K2 going to be 26.94, and this refers that K1 akan lebih laju sebanyak 27 kali ganda bila temperature ditingkatkan from 450 degree to 550 degree Celsius. Okay, so ratio dia adalah 27 kali ganda, seolah-olah 27 bahagi 1 lah. Okay, bila temperature dia adalah 550, sini temperature-nya 450. Okay, or you can also do that in terms of Kelvin. Okay, so this is the answer here. Okay, so this is how you do question number 1B. Now we're gonna move on to the next question here, which is 2A. So ethanol, which is CH3CH2OH, is produced from the fermentation of sugarcane and widely used as an alternative fuel to replace petrol. A 1 gram sample of ethanol was burned in a bomb calorimeter, which has a total heat capacity of 11 kilojoule per degree Celsius and the temperature of the calorimeter and its content increased from 25 degrees Celsius to 27.7 degrees Celsius. So for question number 1, we have to write a balanced chemical equation for the reaction that takes place in the bomb calorimeter. Okay, so kita tahu kita ada ethanol, which is CH3, CH2OH, and then the phase here is important, where the phase of ethanol, which is alcohol, adalah dalam bentuk liquid, and then it's going to burn in excess oxygen, okay, in gas, and this is going to produce carbon dioxide gas and water, okay, which is in terms of liquid. So now this is the equation, but it is not balanced yet, so you have to balance the equation. So the tips here: balance carbon dioxide, balance carbon first, followed by hydrogen, and then balance oxygen. So carbon will have 2, 1 and 2 here, so you need to put number 2 here. Okay, and now for the hydrogen, it's gonna have H3, H2, H. So you're gonna have 6 hydrogen, so you're gonna put number 3 here. Okay, so 2 carbon, 6 hydrogen, 2 carbon and 6 hydrogen, and then for oxygen we're gonna have 4 plus 3, 7. Okay, but here already got 1, so I'm going to add up 3 here. So 6 oxygen plus 1 akan ada 7. 2 darab 2, 4 tambah 3 pun 7. So this is how to write a balanced equation. So the answer going to be CH3 CH2OH liquid plus 3 over 2 plus 3 times oxygen gas produces 2 mole of carbon dioxide gas and 3 mole of water. And now we need to find the enthalpy of the combustion of ethanol per mole. Okay, dan kamu tahu pembakaran itu berlaku dalam calorimeter, bomb calorimeter. And then what being burned is 1 gram of the sample of the ethanol. Okay, so when a sample is burned in excess oxygen, the heat released by the reaction gonna be absorbed by the calorimeter. Okay, and then the heat capacity of the calorimeter is mentioned as 11 kilojoule per degree Celsius. Okay, heat capacity of the calorimeter 11 kilojoule per degree Celsius. And then the increase in the temperature, which is this here is the thermometer, it will increase by 2.7 degrees Celsius. Okay, 27 tolak 27.7 tolak 25. So delta T here gonna be 2.7 degrees Celsius. Okay, so we have to find the enthalpy of combustion per mole. Okay, so first we need to find our Q first. Okay, so Q is equal to C delta T, because the heat released by the reaction gonna be the heat absorbed by the calorimeter. Tiada air kan, jadi dia hanya melibatkan calorimeter. CC multiplied by delta T. So our CC here refer to 11 times 10 to the power of 3. Okay, pasal kilo tadi. Okay, joule per degree Celsius. And then the change in temperature going to be 2.7. So once we plug in the calculator, what we're going to get is 29,700 joule. Okay, so ini adalah haba yang dibebas dan diserap oleh calorimeter. Tetapi sekarang kita nak cari enthalpy of combustion of ethanol per mole. So we need to find the number of mole of CH3 CH2OH that is being burned. Okay, so it involves 1 gram, right? And then we can find the number of mole by dividing the mass with the molar mass. So our mass here going to refer to 1 gram, and the molar mass of the ethanol, okay, going to refers to 46 gram per mole. Okay, so gram divided by gram per mole. So we're going to get a mole, which is 0.02174 mole. Okay, and in order to find the enthalpy of combustion, which is the heat of combustion of ethanol, what we're going to do is we're going to divide our heat, which is Q, divided by N. So our heat absorbed by the calorimeter going to be 29,700 joule, divided by the number of mole of the ethanol that is burned, which is 0.0217 mole. So once we divide that, we're going to get 1366 200 joule per mole, and then we can convert that into kilojoule by dividing it by 1000. Okay, so what we're going to get is 1366 kilojoule per mole. Okay, so this is how we do question 2A1 and 2A2. Now we're going to focus on question number 2B. Okay, so for question 2B, the Born-Haber cycle for the formation of the calcium sulfide is given in the figure 2. Okay, and it was mentioned here the cycle is not drawn to scale. Okay, gambar ini tidak dilukis mengikut skala. Okay, for B1 we have to name the enthalpy change for H7 and H8. Okay, so for this one senang sahaja. Untuk H7, dia adalah daripada gaseous ion, and then it gonna form an ionic solid. Okay, kalau dari solid menjadi gaseous ion, dia adalah lattice dissociation enthalpy. Pasal dia kena break the bond solid menjadi gas. Dissociation enthalpy. Tapi sekarang gas menjadi solid, so it gonna refers to lattice enthalpy. Okay, gas becomes solid. H7. So we can say that H7 refers to the lattice enthalpy of calcium sulfide. Meanwhile, for H8, it involves the formation of 1 mole of ionic solid from its element. So calcium solid with sulfur solid. Okay, so it refers to the heat of the formation of calcium sulfide. Okay, or known as the enthalpy of formation. Okay, now for B2, we need to identify the species of delta H5. Okay, so to understand about this, let us look into the diagram here. So H8 is the formation. H1 here refers to solid menjadi gas adalah atomization untuk calcium. And then here solid become gas again. So it is an atomization of sulfur. And then H3 is basically ionization energy for calcium, and then H4 is second ionization energy for calcium. From calcium plus it become calcium 2 plus. Okay, so sebenarnya masa ionization energy yang pertama, it gonna release 1 mole of electron, and then for the second ionization energy, another electron gonna be add up, so it gonna become 2 electron. Okay, and during delta H5, satu elektron akan ditarik kepada sulfur, so it will undergo first electron affinity. Okay, so dia akan jadi S minus plus electron dalam bentuk gas. And then for H6, dia akan undergo electron affinity yang kedua, yang mana elektron tadi akan diserap lagi oleh S minus menjadi S2 minus. Okay, baru dia akan undergo lattice enthalpy. Jadi X tadi itu adalah S minus gas. Okay, and now for question B3, we have to use the data in figure 2 in order to calculate the value of delta H6. Okay, so nak cari value delta H6. Okay, so for this one senang saja. You can compare H8 is basically the addition of this with this one. Okay, pasal dia adalah starting pergi ending kan. Okay, atau you can go this way ataupun you can go all around the circle, asalkan the initial dengan final point adalah sama. So this one H8 is going to be the same as H1 plus H2 plus H3 plus H4, H5 plus H6 plus H7. Okay, but you need to find the H6. So you just need to substitute the value. So delta H8 is equal to negative 482. H1 is positive 1.78. And then H2 here is positive 279. Delta H3 here going to be plus 590. Delta H4 is 1145. Okay, delta H5 is equal to negative 200. So delta H5 negative 200 kilojoule per mole to negative 200 kilojoule per mole. And then delta H6 is something that you want to find. H7, okay, is negative 303. So ensure that you do not miss out the negative. Okay, so you add up this side first. So negative 482, bila tambah semua ni sekali, kita akan dapat negative 1021 plus delta H6. So you can bring this term on the left hand side. So delta H6 here going to be equal to positive 539 kilojoule per mole. So bila tengok kat sini, logik lah. Pasal dia adalah naik ke atas. So it need to be having a positive value. Okay. So it's going to be 539 kilojoule per mole. And then for question B4, will the energy lattice for the calcium oxide larger or smaller than calcium sulfide? Explain briefly. Okay, so calcium oxide ataupun calcium sulfide, which one have the higher lattice energy? Okay, so for this one, we can say that the calcium oxide will have a higher lattice energy. Okay, this is because the ionic radius of O2 minus is smaller than S2 minus. Okay, bila ionic radius dia makin kecil, okay, so this oxygen, so they are more closely together. Okay, however, when they are big, for example, sulfur, the distance gonna be longer from the nucleus to another nucleus of the calcium. Jadi bila lagi dekat, they have a stronger force of attraction. Okay, so bila ada stronger force of attraction, a higher lattice energy and more energy is needed in order to break the bond. Hence, you can say that the calcium oxide going to have a higher lattice energy. So the explanation, lattice energy of calcium oxide will be larger than calcium sulfide. And this is because the O2 minus have a smaller ionic radius than sulfur 2 minus. Okay, so that's all for question B4. For question 2C, we were given a thermochemical equation here. So this one with the enthalpy of formation of negative 393.5, the sulfur to form sulfur dioxide, negative 296.8, carbon react with sulfur to form calcium disulfide with a enthalpy of negative 87.9 kJ per mole. So we have to determine the enthalpy change for the following reaction, which is the reaction here. So as what you have learned in your lecture and the tutorial, we need to write our target equation first. So our target is this one. So we can write it again, which is CS2 liquid plus 3 oxygen gas produces carbon dioxide gas plus 2 sulfur dioxide gas. Okay, so now we have to use the algebraic method. Okay, so maksudnya kita kena susun-susun reactant with product, and let's say we're going to see whether we can cancel out the compound in order to get to the target equation. Okay, so let us look into the equation one by one. So for equation number 1, okay, so carbon, oxygen and carbon dioxide. So for equation number 1, we can say that the equation will be maintained. Pasal carbon dioxide gas dekat produk, so kita punya target pun carbon dioxide gas pun dekat produk. Dan kita tak payah tukar number of mole pasal dia adalah sama. So for equation number 1, we just gonna maintain it as the way it is. So carbon solid plus oxygen gas gonna produce carbon dioxide gas. Okay. And then for equation number 2, we have sulfur plus oxygen gas, sulfur dioxide. So sulfur dioxide, sulfur dioxide. Okay, position is already correct. Produk dekat produk. Tapi sekarang dia ada 2 mole. Okay, So what I can do is I can multiply equation number 2 multiply by 2. So equation 2 multiply by 2. So it's going to become 2 sulfur plus 2 oxygen gas produces 2 sulfur dioxide. Okay. And then remember my thermochemical equation, which is negative 296.8, mesti darab dengan 2 because I already multiplied everything by 2. So negative 296.8 multiplied by 2 kilojoule. Okay. And now for equation number 3. So bila tengok equation number 3, CS2L dia dekat produk, tetapi our target is at the reactant side. So what I can suggest is that we're gonna reverse the equation. Yang produk menjadi reactant dan reactant menjadi produk. So for equation number 3, I'm gonna reverse it. So what I'm gonna get is CS2L produces carbon and 2 mole of sulfur. And then because I reverse the equation, my negative will become positive because I'm going to reverse the sign. Okay, so it's going to become positive 87.9 kilojoule. Okay, so lepas dah buat 1, 2 dan 3, what we're going to do is we're going to cancel out what we can cancel. So carbon sulfur can be cancelled out. 2 sulfur solid can be cancelled out. And then this one, reactant dengan reactant, kita boleh combine. Okay, so dia akan jadi 3 oxygen gas. Okay, so lastly, you're going to write it back again, which is your reactant, which is the carbon disulfide liquid, plus 3 oxygen gas produces carbon dioxide plus 2 mole of sulfur dioxide. So sama macam kita punya target. Okay, and then for finding delta H, we're just going to add up all of our enthalpy here. So negative 393.5 plus negative 296.8 times 2 plus 87.9. Okay, berhati-hati ya, sini mesti plus pasal kita dah reverse kita punya equation. So negative tadi menjadi positive. Okay, so if you add up all together, what you're going to get is negative 899.2 kilojoule per mole. Therefore, you can say that the enthalpy of the reaction is negative 899.2 kilojoule per mole. Okay, so that's all for tutorial for the past question 2. Okay, for question 3, the standard reduction potential for copper 2, chromium 3, and nickel 2 ions are given below. Okay, so for copper reduced to copper solid going to be plus 0.34, chromium to chromium solid is negative 0.74 volt, nickel to nickel solid going to be negative 0.25 volt. So for tutorial for question 3A1, we have to arrange the metal in the order of increasing strength of the reducing agent. Give your reason. Okay, so the stronger the reducing agent, okay, the stronger the reducing agent means that it will undergo oxidation better. Okay, so oxidation are basically happening at the anode, and for the reaction to happen at anode, the E0 cell going to be more negative. Okay, so by understanding this idea here, we can now arrange the metal according to its E0 value. So out of these three things, the more negative one going to be the chromium solid. So the chromium, number 1. Second going to be followed by the nickel solid, and then number 3 going to be followed by the copper solid metal. Okay, so the chromium will undergo oxidation better to form chromium 3+, followed by nickel, and then followed by copper. Okay, so that is how we arrange our reducing agent. Next, for A2, we need to determine the reaction below whether it is spontaneous or not under the standard condition. So spontaneous, so we have to look at the spontaneity. Okay, spontan ke tidak. So in order to answer the question of spontaneity, it is advisable to write back the equation. Okay, Cu2 plus aqueous plus chromium solid produces copper solid plus chromium 3 plus aqueous. And then we need to decide which ions will undergo reduction and which ion will undergo oxidation. So as what you can see, the copper 2 plus will undergo reduction into produce the copper solid. So it will undergo reduction. The chromium solid will undergo oxidation to produce chromium 3 plus. There's going to be an increase in the oxidation number. So this one is oxidation. So reduction happens at cathode, pasal red cat, kucing merah, and oxidation happens at anode. Okay, anox. Okay, oxidation. Anode undergo oxidation. Seekor seladang. Okay, so in order to determine whether it is spontaneous or not, we need to find our E naught cell. So our E naught cell is basically equal to E naught cathode minus E naught anode. So our E naught cathode, which is the copper 2 plus to copper, kita ambil balik yang SRP value, which is positive 0.34, and then kita punya anode adalah Cr to Cr3 plus. But then we need to take the SRP value, which is negative 0.74. Okay, so negative and negative, yang E naught is negative 0.74. So ensure that you don't miss out any negative. So once you do the math, you will get positive 0.184. So since your E naught cell is positive, you can say that it is a spontaneous reaction. Okay. Now for question A3, we have to explain what will happen if the chromium container is used to store the copper sulfate solution. Okay, so kita ada container chromium. Dalam tu kita isi dengan copper sulfate solution. So what do you think will happen? So this situation here is the same as the reaction here. So you know that the chromium will undergo oxidation to form chromium 3 plus. Pasal dia punya SRP value yang berbeza. Okay, so the first explanation that you can say is that the chromium container will undergo oxidation to form chromium 3 plus. Meanwhile, copper 2 plus will undergo reduction to form copper solid. Okay, dan disebabkan ada reaction tadi, what gonna happen is that it gonna causes contamination. Okay, maksudnya ada perubahan ion. Sepatutnya dia hanya mengandungi copper 2 plus. Tetapi chromium tadi telah masuk ke dalam solution tu menjadi chromium 3 plus. So dah ada contamination. Okay, maksudnya dah ada tindak balas yang tidak sepatutnya lah. Okay, and then this will show that the chromium container is not suitable, tidak sesuai, in order to store the copper sulfate solution. Okay, so that's all for question 3A3. For question 3B, the zinc plating, which is the galvanized zinc, is an important means of the corrosion protection. One of the possible ways in which this can be achieved is through electrolysis. So how many grams of zinc can be deposited on steel object if a current of 1.2 ampere is passed through the zinc sulfate solution for 1 hour? Okay, so in order to know how many grams that are deposited, first we need to find the amount of charge that is flow in the circuit first. So we need to use our Q is equal to IT. So our I here is equal to 1.2 ampere. Okay, this one refers to I. And then our T here need to be in the unit of second. Mesti dalam unit saat. So 1 hour, we can change that into 60 minutes by multiplying by 60. And then minutes, okay, we can multiply that with another 60 seconds. Okay, so 60 times 60 gonna have 3,600 seconds. Okay, so 1.2 times 1 times 10, 1 times 60 times 60. So what we're gonna get is 4,320 coulomb. Okay, and then you also know that 1 Faraday is equal to 1 electron is equal to 96,500 coulomb. Okay, so this is based on your list of constant. Okay, But now you only have 4,320 coulomb. Okay, so 4,320 coulomb will produce how many electron? So X here. So what you're going to do is you're going to cross multiply. Okay, so your X here going to be 0.0448 electron. Okay, and now you at the cathode, you know that zinc will going to be deposited. So you know that they're going to be in the circuit, the zinc going to be deposited on the steel. Okay, so you know that they're going to be electron that passes through the zinc, and the zinc 2 plus ion going to accept 2 mole of electron in order to produce zinc solid. So you need to come up with the equation first. Okay, but essentially bukannya 2 elektron yang melaluinya, tetapi hanyalah 0.048 elektron. Okay, pasal the amount of charge yang dilalui dalam circuit tersebut. So what we're going to do is we can compare where 2 mole of electron will produce 1 mole of zinc. Okay, but if we have 0.048 electron, how many mole of zinc we're going to get? So we're going to cross multiply. So our Y here we can get is 0.024 mole of zinc. Okay, so from the mole we can find the mass, where mass is equal to mole multiplied by molar mass. So okay, mass is equal to, sorry, here going to be mole multiplied by molar mass. So our mole here going to be 0.0224 mole multiplied by the molar mass, which is gram per mole. So mole per mole and mole can be cancelled out, and then 0.0224 times 65.4, what we're going to get is 1.465 gram. So zinc, the amount of zinc that's going to be deposited at cathode going to be 1.465 gram. Okay, so this is how we're going to answer question 3b. Okay, for question 4, the propane will undergo free radical bromination to produce compound A. So we have to draw the intermediate form and the structural formula of A. Okay, so propane gonna have 3 carbons, so it's gonna become 1, 2, and 3, and then it's gonna undergo bromination, which is bromine molecule. When talking about free radical, you know that it's gonna happen in the presence of UV. Okay, so here it's gonna produce a major and minor product. So the major product gonna be at this part here, because it's gonna become a more stable intermediate, which is like this. So this one gonna be the major product, and then like this gonna be the minor product. Okay, but for this question we only focus on the major product, because the major product gonna be the dominant product. Almost 90% gonna be this part here. Okay, so for the equation A, they ask us to draw the intermediates form and the structural formula of A. Okay, so you know that from the reaction we're going to produce our A here, which is the major product. Okay, and as for the intermediates, it's basically come from the mechanism, but you don't have to show them. Okay, you can just see that during the initiation step, you know that the bromine and bromine gonna be dissociated, so gonna produce Br free radical and another Br free radical. Okay, at step number 2, you know that the alkene here will gonna react with the free radical. So half-headed arrow and another half-headed arrow, and then this one gonna produce here. So this gonna produce intermediate of free radical plus HBr here. Okay, so step 1 and step 2. Okay, and this is going to be your intermediate instead of this one, because secondary free radical is more stable, which allows in the formation of the major product. Okay, and another intermediate is the bromine. Okay, and that is why bromine can react with Br in the termination step. Okay, so bila dia nak stop the reaction termination, Br akan react balik dengan Br untuk form bromine, and then the free radical of the propane gonna react with Br, and this gonna produce the answer here, which is A. Okay, so the two intermediates gonna be this one and this one. Okay, so the intermediates gonna be the secondary free radical of the propane as well as the bromine free radical, which comes from the initiation step. And then our structural formula here is that when the free radical combine together in order to produce 2-bromopropane. Okay, so that's for question 4A. And then for question 4B, we have to draw the structural formula of B, C, and D, name a simple test. Okay, so we have to read the question in here. So it just say that hydrocarbon B, C6H12, react with 1 mole of hydrogen gas over platinum catalyst to produce compound C. Oxidation of B forms carbon dioxide and carboxylic acid D. So kita kena draw the structural formula of B, C, and D and name a simple test to differentiate B and C. So we need to come up with an idea or plan first. So our idea is that we have compound B, which have C6H12. Then B itu adalah hydrocarbon, can be alkane or alkene. Okay, tapi dah nampak C6H12 ni, dia adalah alkene lah. Okay, pasal general formula dia. Okay, so the alkene gonna react with 1 mole of hydrogen gas over platinum, and this gonna produce compound C. Okay, so selogiknya alkene will undergo hydrogenation to produce alkene. Alkene, this one is alkene. And then the B here will undergo oxidation. So I'm just going to put it as bracket oxygen, which refers to oxidation. And this is going to produce carbon dioxide as well as compound D, where D here refers to the carboxylic acid. Okay, and the C here, you know that because it's going to produce an alkene, you're going to add up 2 hydrogens, so it's going to become C6H14. Okay, so you know that it has 6 carbon and then it is an alkene. So the general formula is C6H12. So you know that it's going to be a straight chain alkene with 6 carbon. 1, 2, 3, 4, 5, 6. Okay, but now we need to decide where is the double bond. So in order to decide that, we need to look at the product here. So we got carbon dioxide and carboxylic acid. Okay, so carbon dioxide comes when there is C double bond with hydrogen and hydrogen. So when it broken down, this is going to produce, the C here going to produce carbon dioxide and water when it is being oxidized. So we know that the double bond going to be at the end because it's going to produce carbon dioxide. Okay, so the most appropriate answer going to be 1 hexene here. 1, 2, 3, 4, 5, 6. So our B gonna looking something like this. 2, 3, 4, 5, 6. Okay, so it's gonna be 1 hexene. And then for C, because it undergo hydrogenation, the double bond gonna become single bond with hydrogen and hydrogen. So C gonna be looking something like this. And then for D, because it undergoes oxidation using KMnO4, because it produces carbon dioxide here, so it's going to be oxidized. And then what's going to happen here is that this is going to become oxygen, and then it's going to become OH. Okay, so it's going to have 5 carbon because the other carbon going to release by carbon dioxide. 1, 2, 3, 4, 5. Okay, so what it's going to produce is the pentanoic acid. So D going to produce a carboxylic acid, which is the pentanoic acid. Okay, so 5 carbon here, and then 1 carbon is released to become carbon dioxide. Okay, and now we need to name a simple chemical test in order to differentiate B and C. So B is alkene, and then our C here is an alkane. So we can differentiate alkene and alkane easily using bromine test. Okay, so bila ada bromine, the alkene gonna decolorize the reddish brown color, and then the Br and Br gonna inserted here. Okay, so this is how we're gonna answer question number 4 of the past year question. For question 5, based on the following reaction scheme, we need to give reagent E, F, and G, and then draw the structural formula of H. So given here is the scheme here, and then we need to give reagent E, F, and G, and then draw the structural formula of H. So for E, we know that it started up from benzene, and then it's going to become nitrobenzene here. Okay, so there's going to be addition of NO2. So we know that what we're going to add is NO2, and then the reagent here, we need to use HNO3, H2SO4, which is both are concentrated, and then it happened at the temperature of 50 to 55 degrees Celsius. So you need to mention all of this, including the temperature. Okay, so for E, the reagent that you need to use is the concentrated nitric acid, concentrated H2SO4, as well as the temperature. So the H2SO4 here will act as the catalyst in order to initiate the chemical reaction. Now for F, you start with the benzene. Okay, and now you're going to add up an alkene chain here. So this process is known as the Friedel-Crafts alkylation sebab ada pertambahan alkyl group. Okay, yang tadi adalah nitration pasal pertambahan nitro group. Okay, so what you're going to add is CH3, H, and then one of those need to be any haloalkane, so X. Okay, and then it needs to happen with the presence of FeX3. Okay, so let's say if I'm choosing Br, and then here need to be Br3. Okay, so it's going to be CH3. So for F, my reagent going to be CCH3CH3HBr, which is 2-bromopropene, including with the FeBr3 as a catalyst. Okay, now for G, we have our side chain here. But now it's going to become a benzoic acid. Okay, which is COOH, and then we have the alkyl chain. So alkene chain can be converted to benzoic acid by the process of oxidation. So for oxidation, we can use strong oxidizing agent, for example, KMnO4 at acidic condition at high temperature. So you need to mention all of this in order to get 1 mark. Okay, so for G, we're going to use KMnO4, H plus and strong, H plus and at high temperature, which is heating here. Okay, so everything need to be mentioned in order to get 1 mark. And then for H, we will be using Cl2 in the presence of UV. So we will undergo the process of free radical substitution. Okay, and as you know that the chlorine can substitute the hydrogen in the middle, or chlorine can substitute the hydrogen at the this side here at the end. Okay, tetapi chlorine akan lebih higher probability untuk substitute H dekat sini kerana dia adalah tertiary haloalkane. Okay, so what they're going to produce here is that CCl. Then the other going to be CH3 and CH3. So the hydrogen, the chlorine will substitute the hydrogen here in order to produce major product. Okay, if minor, we will get the answer to be something like CH2Cl. Okay, tapi soalan nak major product, jadi kita we're gonna draw the major product only, where this one is a tertiary haloalkane. Okay, so that's all for question 5A. Okay, for question 5B, we have to write the mechanism for the formation of the isopropyl benzene. So for the isopropyl benzene, it is the same as the reaction scheme that you have seen for part F. Okay, so from benzene, it's going to become isopropyl benzene. Okay, and here adalah isopropyl substituent lah. Okay, that is why it is named as isopropyl benzene. And our F here is the same as what we have identified in the 5A. So we're going to use CCH3, CH3, HBr, which is 2-bromopropane. And our catalyst here going to be FeBr3. Okay, and the 2-bromopropane can also be written as CH3 2 CHBr. Okay, sama maksud sahaja. Okay, so untuk penulisan, I think I will use this one because I want to save up the space. Tapi kalau kamu nak buat secara expanded pun, it is still accepted. Okay, so for step 1, which is the formation of electrophile, what we're going to do is we're going to react our 2-bromopropane with the catalyst, which is FeBr3. So the bromine, which has a lone pair, going to attack the catalyst at the fluorine atom. So what they're going to produce is a complex, which is the CH3-2CHBr, and then they're going to be forming a bond in between the bromine with the fluorine, or with the ferrum. Okay, so a bond going to be formed, and as a result, the bromine will carry a partially positive charge, and the ferrum going to carry a partially negative charge. Okay, and now we're going to break the bond in between the carbon with the bromine. Okay, because you can imagine the hydrogen to be up here. Okay, so the CBr bond going to be broken, and 2 electron passes back into bromine. Okay, and as a result, what we're going to produce is a secondary carboxyl ion. Okay, so it's going to look something like CH3, CH3, CH, and then positive charge here. Okay, which is this is the electrophile that we need in order to insert it here. Okay, at the same time, we're also going to be producing our BrFeBr3, which is 1 Br from the haloalkane is now transferred into the catalyst, and it's going to carry a negative charge. Okay, so the most important thing here is the formation of the electrophile here. Okay, now we're going to move into the next step, which is step 2, formation of aranium ion. So we have our benzene, and now we're going to react that with our electrophile. So it will happen simultaneously. Dia akan berlangsung secara berterusan. Okay, so benzene, which has a carbon-carbon double bond, going to act as a nucleophile. So nucleophile akan menyerang electrophile. So nucleophile going to attack the electrophile because it has more electrons. Okay, so as a result, the carbon going to be attached to the benzene ring. So it's going to become CH3, and then CH here. So almost the same as the answer. Okay, but I'm going to use it as this one because I want to save up the space. Okay, you can also draw it in terms of the expanded form. Okay, so you know that the carboxyl ion is already attached with the benzene, and then now At the same time, the uranium ion can be formed because it have a positively charged here. So there's going to be a delocalization of electron inside the benzene ring. So the 2 electron here can be transferred into this end here in order to make a double bond. And as a result, the positive charge is transferred into here. Okay, and the delocalization of electron happens again where 2 electron going to be transferred into here, and then the positive charge going to be here. Okay, so we have to show the formation of the uranium ion, and then we need to enclose it with a bracket. Okay, so meaning that ada banyak possibility untuk resonance structure untuk benzene tersebut. Okay, and for step number 3, which is the deprotonation of uranium ion, you can select this structure, you can draw it again, or this structure, you can draw it again, or this structure, you can draw it again. So pilih salah satu. So for me, maybe I will take this one. Okay, so if I were to take this one, it's going to looking something like this. And then I'm going to use my catalyst again, which is the BrFeBr3. So I'm going to use it again in step number 3. And what's going to happen here is that I'm going to break the bond in between Br and FeBr3. Okay, and Br here going to have the lone pair. So the lone pair is going to be used in order to take up the hydrogen, and the bond of CH going to be broken and transferred into the benzene ring in order to hilangkan H positive charge tersebut. So as a result, I'm going to get a benzene ring with a triple carbon-carbon double bond, and CH3 2 going to be attaching here, which refers to the isopropyl benzene. Okay, and then Br and H going to be attached together in order to form HBr, and then FeBr3, which acting as a catalyst, you will get it again. Okay, dan bila nampak kat sini kita tahu mekanisme tu betul pasal FeBr3 adalah catalyst, so it will not take part in the reaction dan kita akan menghasilkan dia balik at the end of the reaction. Okay, so this is how you do the mechanism for the formation of the isopropyl benzene, yang mana yang ini adalah sama dengan structure begini. Okay, sama sahaja. Okay, now for question 6, we have 1-chlorobutane which reacts with the sodium hydroxide as shown in the chemical equation below. So we have the 1-chlorobutane here, and then it's going to react with the sodium hydroxide, and this going to produce the Cl going to be substituted with OCH3, which inserted here. Okay, so kat sini adalah sodium hydroxide, so it's going to have Na plus as well as OCH3 minus. Okay, so O negative CH3 will act as a nucleophile. Okay, so for question 6A1, we have to name and draw the mechanism involved. Okay, so kat sini 1-chlorobutane adalah primary haloalkane. So primary haloalkane. And then O negative CH3 is a strong nucleophile. Okay, so for a primary haloalkane, it will undergo SN2 mechanism, and it's going to consist of one step. Yang mana step tu adalah akan ada transition step, transition state, and then it happens for the primary haloalkane. And the primary haloalkane will be favorable when they're going to be a strong nucleophile. Okay, so kat sini kita tahu dia akan undergo SN2. Kalau SN1, dia akan ada dua step, and it is for tertiary haloalkane. Okay, so kamu akan ingat 1, 2, 3. Tapi kalau untuk SN2 dia adalah 2, 1, 1. So primary haloalkane akan undergo SN2. Okay, so name and draw the mechanism involved. So untuk name, you can write the full name, for example, because it's number 2, right? So it's going to be bimolecular nucleophilic substitution. Okay, by molecular nucleophilic substitution. So refer kepada SN2, or you can write it as SN2. Dekat sini N wajib untuk small letter. Okay, so dia kena acting as a subscript. S is capital and 2 is the big one. If you write it this way, then it is wrong. Okay, so please be very careful. So this one going to be accepted and this one will also be accepted. Okay, and now we're going to draw the mechanism involved. So we know that it consists of one step and then the strong nucleophile going to attack it straight away. So we're going to draw our chlorobutane. So the chlorobutane here, I can draw it in terms of the 3D form. Okay, so you know that it's going to become CH2, Cl, and here going to be CH2, CH2, and then CH3 here. So this carbon here going to become the center, and then hydrogen, and then Cl, and then the other part here CH2, CH2, CH3 going to become upwards. So for the SN2 mechanism, we need to draw it in terms of 3D. Okay. And now the methoxide ion. So methoxide ion is a strong nucleophile because it have a negative charge. So the strong nucleophile going to attack the partially positive charge of the carbon, and here going to attack here, and as a result the CCl bond going to be broken. Okay, and this is going to produce a transition state where H3CO will have a dotted line here. So bond seolah-olah hampir nak terbentuk, almost forming, and CCl here you will say that it almost breaking. Hampir nak terbentuk, sini hampir nak terputus. Pasal dia akan masuk membentuk bond, ini akan terkeluar. Okay, and this happens in the present at the transition state, yang mana kita akan label it using a double dagger symbol, and then we're going to label it as a transition state. Okay, and at the end of the reaction, it is a fast process because H3CO akan betul-betul terhasil dan Cl ni akan betul-betul terkeluar. Okay, and as a result, kita akan inverse the configuration. So kalau nampak kat sini, mula-mula dia akan bentuk seolah-olah macam penyapu. Okay, tapi at the end of the reaction, what you're going to see, it going to have a inverted configuration. So tadi dia akan bentuk tiga mencapah begini, and at the end of the reaction, it going to become like this because it is a strong nucleophile, so it's going to attack and then it's going to push everything apart in order to become on this side. Okay, so ensure that you draw the 3D form correctly. So dia mesti inverted configuration. Okay, and this whole step here sebenarnya dikira sebagai satu step. Dan ini kita hanya menunjukkan dia punya transition state, yang mana transition state ni tidak dikira sebagai satu step. Okay, so sini ke sini sebenarnya adalah satu step. Okay, and now for 6A2, we need to write the reaction rate equation. So we know that it is SN2, so the rate gonna be depending on both of the haloalkane as well as the nucleophile. Okay, tapi kita tak boleh tulis macam ni. Ini adalah secara general. We have to be specific. So we have to write rate is equal to the K, which is rate constant, and then our haloalkane, which is Rx, going to become CH3, CH2, CH2, CH2Cl. Kita salin semua balik one chlorobutane, and then our nucleophile is NaOCH3, which is this one. Okay, so ensure that you are being specific to the question. Okay, dan kat sini pun tadi kita kena tambah Cl minus pasal Cl dah mula terkeluar. Okay, So that's all for question 6A1 and 6A2. For question 6B, we need to complete the reaction scheme by giving the reagent J and then the structural formula of K and L. Okay, so here it is an alkene, which is 1 propene. And then we're going to be producing K. And then our K here will undergo a reaction with magnesium in dry ether in order to form MgCl. Okay, so dekat sini, I need to get in my K, I need to have Cl and hydrogen. So I know that my J here, I need to add up HCl. Okay, supaya hydrogen boleh masuk dan chlorine boleh masuk, and then it will undergo reaction with magnesium in order to produce MgCl. Okay, so kat sini my J gonna be HCl, and then it will undergo addition reaction follows the Markov-Nikov rule. Okay, kena follow Markov-Nikov, maksudnya hydrogen akan masuk kepada carbon which has more hydrogen attached to it. So it's going to become CH3, C, C, H, H, dan H. Bulatkan tadi. Okay, and the Cl which going to be added akan masuk di tengah-tengah. Okay, so this is my structure of K. And then from K, magnesium akan masuk dekat sini in order to produce this structure here. So I know that my K here going to be correct. Okay, so my reagent J going to be HCl, and then my K here going to become 2-chloropropane. Okay, where we have to follow Markov-Nikov pasal hydrogen masuk ke carbon yang ada more hydrogen attached to it, and chlorine will enter in the middle. And then this structure here, the K, will undergo reaction with magnesium in dry ether in order to produce MgCl. Okay, and then MgCl here will undergo reaction with carbon dioxide and H3O plus in order to produce carboxylic acid. Okay, so ini nama dia adalah carbonation of Grignard reagent. So what's going to happen here is that it's going to become H3C, CH, CH3, and then carbon dioxide going to be enter here, and then it's going to be form MgCl. Okay, and then it will the first step adalah carbon dioxide kan. Okay, so it's going to become C double bond O, MgCl, and then the second step it will undergo hydrolysis. Okay, so the MgCl here going to be removed and replace it with hydrogen. So at the end it's going to produce a carboxylic acid. Okay, so the carboxylic acid going to look to be something like this. COOH. Okay, so it's going to become 2-methyl propanoic acid. So our L here, you basically remove Cl with COOH in the presence of carbon dioxide and H3O plus. So this is the structure here. And then if the naming going to be 1, 2, 3, so it's going to be propanoic acid, and then methyl group is attached to carbon number 2, so it's going to be 2-methyl propanoic acid. Okay, but the drawing of the structure is sufficient. The naming is just extra. Okay, you don't have to write the naming, just for your practice. Okay, so for question 7, compound M and N are isomers with the molecular formula of C5H12O. The reaction of M and N with sodium metal will gonna form gas bubble. When M is heated with acidified solution of sodium dichromate, orange solution turns green, so means that oxidation happens, and compound PC5H10O2 is formed. N does not decolorize acidified sodium dichromate solution. So kalau baca macam ni kan, confirm tak faham. So what I suggest you to do is to come up with an idea. So if you were to read the question again, you can do a plan or a sketching. So compound M and N are isomers with the molecular formula of C5H12O. Okay, and then you know that the reaction of M and N, okay, reaction of M with the sodium metal gonna form gas bubble. Same goes to the reaction of N with the sodium metal. So N gonna react with sodium metal will also produce gas bubble. Okay, settle with this sentence. When M is heated with acidified solution of sodium dichromate, when M is heated with the sodium dichromate solution at high temperature and at acidic condition, it will going to say that orange solution turns green. So orange will turn green, and then a compound P, which is C5H10O2, is formed. So compound P, which has a molecular formula of C5H12O2, C5H10O2 gonna be formed. And then N does not decolorize. Okay, N does not decolorize Na2Cr2O7 H plus at high temperature, and this gonna give a no observable changes. Okay, so you know that between M and N, M can undergo oxidation and M can undergo reaction with Na. For N, it cannot undergo oxidation. Okay, so by looking at this general formula here, which is C5H12O, you know that it's gonna be an acid. Okay, and then Na here is a base, so acid and base can undergo reaction together. Okay, but this is not a carboxylic acid because oxygen here only have one, so the most logical one is gonna be alcohol. Okay, because it only have one oxygen. Carboxylic acid must have two oxygen, so it cannot be carboxylic acid. Okay, so M here need to be alcohol, and then it can be oxidized to form C5H10O2. Okay, so when there is O2 here, you know that it will undergo oxidation to form carboxylic acid. Okay, so only primary alcohol can undergo oxidation to form carboxylic acid. If secondary alcohol, it will oxidize to form ketone. So ketone will only have one oxygen, but here have two oxygen. So you know that here need to be primary alcohol. Okay, so M need to be primary alcohol, not secondary. Sebab kalau secondary, oxygen dia mesti satu, tapi formula kat sini ada O2. Okay, but for N, it also be an alcohol. However, it cannot be oxidized. Okay, so the one that cannot be oxidized is a tertiary alcohol because it does not have any hydrogen to be oxidized. Okay, so you know that M going to be primary, N going to be tertiary alcohol. So for C5H12, you can draw M to be having 5 carbon. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5, and then OH here. Okay, so it's a primary alcohol because this carbon here is attached with one OH group. So M going to be like this, okay, which is a primary alcohol. Okay, and if you prefer to write CH3, CH2, 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 OH, it is also accepted. Okay, so you can draw either in the skeleton structure or in terms of condensed structure, both are accepted. Okay, and then you might also be asking, sir, instead of I'm using 5 carbon here, can I do a branch? Yes, you can. Okay, so let's say if you're making 1, 2, 3, and then 4, and then the 1 carbon chain here you're going to put here, it is also accepted. Or you want to put here, is also accepted because it is still a primary. So there's basically for M, there are going to be a lot of answers. Okay, as long as it is primary, then the answer going to be accepted. Okay, the keyword you need to know is you need to be consistent. So if you decide to use this one, all the following question you need to use back to the one that you have decided. Okay, yang penting kena konsisten. Kalau M kita dah macam ni, kita teruskan juga M kita macam ni. Okay, tapi jawapan lain kalau nak jadikan the branch pun boleh diterima. Asalkan konsisten lah sampai ke ujung. Okay, so that's for question M. So that's for M. And then M can be oxidized into P. So you know that the primary alcohol can be oxidized into carboxylic acid. So it's gonna become double bond O, OH. Okay, so P gonna become double bond O, OH. So it's gonna become a carboxylic acid. Meanwhile for N, you know that it's gonna be a tertiary alcohol. So your OH need to be attached. This carbon here need to be attached with, this one is 1, 1, 2, 3, and then 4. So total must have 5 carbon. And then this carbon here must be tertiary. So it need to look something like this. Okay. Okay, so you can also write it as in terms of like this, as long as this carbon here is a tertiary alcohol because it's attached with 1, 2, and 3 alkyl group, and then the number of carbon here is 5, which is still consistent to C5H12O. Okay, so your structure of N gonna look something like this. Okay, so if you want your ethyl to be at the middle, is also okay, and it doesn't matter as long as it is tertiary alcohol. Okay, now for question B, we have to write all the equation involved, write all the chemical equation involved. So for M, we know that we have decided on this structure here, so we need to be consistent. So our M here going to look something like this, and then it's going to react with Na. Okay, so for this one, please label is as M. M react with Na. So what it's going to undergo is the formation of salt. So it's going to become O minus and Na plus. Okay, and what's going to be released is the hydrogen gas. So that is why a gas bubble going to be formed, because hydrogen gas going to be released. Okay, and then M can also react with, okay, please label it with M. React again with the sodium dichromate, and then at acidified condition at high temperature. So what's going to happen here is the formation of the carboxylic acid. Okay, at the same time, the N here, which is our N, which is the tertiary alcohol, can also react with the sodium metal, and then it's going to produce a salt, which is O minus and Na plus. So as what you have decided here, you need to be consistent. Okay, so kalau M kamu macam ni, so you have to write it, your M in part B to be the same as the one that you have decided. Okay, kalau kamu punya M 1, 2, 3, 4, okay, if your M is like this, so your M need to be also like this lah. Okay, kena consistent. Kalau kamu lukis begini, kena begini. Kalau begini, kena lukis yang sama jugalah. Okay, tapi yang nak senang, gunalah straight chain saja. Okay, so that's for A and B. For question C, we need to look into the next slide. So for question C, we have to write the structural formula of the product form when P react with M. That the catalyst used. So our P just now is the carboxylic acid, and then our N is the one that we have drawn. So let's do it again. So P is our carboxylic acid, and it's going to react with N, which is our tertiary alcohol. So what it's going to undergo is the esterification, because this one is carboxylic acid, and then it's going to react with alcohol. So OH going to be removed and hydrogen going to be removed. So it's going to be attached straight away to the oxygen with this branch here. So what you're going to get at the end is it's going to link straight away to O, and the carbon chain here going to be maintained. 1, 2, 3, 4, 5. So it's going to be 1, 2, 3, 4, and 5. So still maintained. Okay. And then for the esterification to occur, we need the catalyst, which is the concentrated H2SO4 in the presence of heat. Okay. So the catalyst that we need is the concentrated H2SO4 in order to promote esterification between carboxylic acid and alcohol. Okay, so that's all for tutorial. That's all for question 7. So for question 8, based on the following reaction scheme, we have to draw the structural formula of Q, R, and S. Okay, so given here in the middle is CH3, CH2, CHO. So here basically refers to aldehyde. Okay, so it can be drawn as C-O-H here. Okay, so aldehyde gonna react with Grignard reagent with H3O+, and this gonna produce a primary alcohol. Okay, and here you can see that the benzene ring attached with Grignard reagent, it's gonna attach with this carbon here that is attached with the aldehyde group. Okay, so it's gonna become C, H, and then it's gonna become CH2, CH3, and then the oxygen at carbon gonna become OH because it undergo hydrolysis. Okay, so it's gonna be Q can be drawn as something like this, which is CHOH, and then it's gonna become CH2, CH3, or you can also draw it in terms of the skeleton structure here. So 1, 2, 3 carbon. So carbon number 1 is attached with OH group. Okay, and then for R, so you know that CN is a nucleophile. So it's gonna attack at this carbon, and then the double bond O gonna break and take up the hydrogen from the HCN here. So it's gonna become a cyanohydrine, where R here gonna be the same as this structure here, but we add up with CN and OH. Okay, so you can also draw it as CH3, CH2, C, Cn because Cn enter, and the double bond O gonna become OH, and then hydrogen. Okay, or you can also put it in terms of this way. It is still the same. Okay, and then for S, the aldehyde will undergo reduction using the lithium aluminum tetrahydride followed by hydrolysis. So what's going to happen here is that when it undergo reduction, it's going to become CH3, CH2, CH2, and then OH. Okay, so it's going to become a primary alcohol. So you can also draw it in terms of CH3, CH2, CH2, OH, which is a propanol here. Okay, so that's for question 8a. For question 8b, the compound TC4H8O will form an orange precipitate with British reagent, and the treatment of T with alkaline iodine solution will give a yellow precipitate. So for B1, we have to explain the observation and then draw the structural formula of T. So the first thing that we're going to do is we're going to extract the information. So we know that T will have the molecular formula of C4H8O, and then it's going to form an orange precipitate with the British reagent. So this is going to give a positive result. So we know that our structure here will have C double bond O. Okay, sebab British reagent kalau dia menghasilkan orange, dia akan detect presence of C double bond O. So we know that the structure T here will have a carbonyl compound. And then the T here will also give a yellow precipitate when reacted with iodine in their basic condition. So the iodoform test is used in order to detect methyl carbonyl group. Okay, so it means that C double bond O, the structure T here must have C double bond O and CH3. Okay, so the observation here will give the structure of this one, and the other observation here will give the structure of like this. Okay, so we know that C double bond O CH3 will use up C2 H3 and O, but the balance that we need to add up in order to produce C4H8O is C2H5, so that we're gonna get C4H8O. So C2H3 is basically equal to CH2CH3. So the CH2CH3 we can add up here. Okay, so we can get our structure T to be something like this. Okay, and it is also consistent to C4H8O. 1, 2, 3, 4, C4. Hydrogen gonna become 3 plus 3 plus 2 gonna be 8. Oxygen got 1. So I know that my structure T here gonna look something like this. Okay, I can also draw it in terms of skeleton structure, or can draw it in terms of the content structure here. And now I'm gonna explain it. Okay, so T is basically a ketone with a methyl carbonyl group. This is because T has C double bond O, which is the carbonyl group. Thus, it will give a positive result with the Bright's reagent. Also, T will have the CH3 C double bond O, which is the methyl carbonyl group. So it's gonna give a positive result with the ionoform test, which give a yellow precipitate. Okay, and this is how we answer question B1 here. For question B2, ozonolysis of an alkene U produces only T. Okay, state the reagent used and suggest alkane U. So, produk yang kita akan hasilkan hanya T sahaja. So we have to predict what is the alkene U. Okay, and in order to do this, we can draw back again the structure, and then because it undergo ozonolysis, right? So you know that it comes from the cleavage ataupun pemotongan daripada alkene tu. Okay, so you can draw it to be something like this. Okay, sebab if I were to cut the carbon-carbon double bond, what I'm going to produce is to be something like this. And this refers to product T, and this will also refers to product T. Okay, dan dia hanya menghasilkan produk T. I cannot draw it to be something like this or like this, because if I were to cleave, I will get this product and I will also get this product. So two different products. So I cannot draw it this way. I need to draw it this way so that I can get both of my product to be T. Pasal disebut only T. Okay, so basically 1, 2, 3, 4 carbon, you need to double it into 8 carbon, and then you have a double bond in between. Okay, so your structure U here is to be looking something like this. Okay, so you're gonna cleave to produce T, and then the reagent that we're gonna be using is the ozonolysis. Okay, because it says ozone, and then the other reagent is using zinc H2O with H+. Okay, so here this one refers to the reagent. Okay, 8 carbon menjadi 4 carbon. Alright, so that's all for question at B. So for question 9, we have to arrange the compound below in the order of increasing acidity. So for acidity, we're going to look into the conjugate base, where the conjugate base means that the acid will lose its hydrogen. And the more stable the conjugate base means that it's going to be more acidic. Okay, so for phenol, this is the structure of phenol. When it loses H+, it's going to produce a conjugate base of the phenoxide ion. Okay, this is phenoxide ion, and this is the conjugate base. So for the phenoxide ion, the negative charge is delocalized inside the benzene ring, which involve carbon and carbon atoms. Okay. Meanwhile, for propanoic acid, it will consist of 1 to 3 carbon, and then it's going to involve carboxylic ion. So the negative charge gonna delocalize inside the carboxylic ion, which involve 2 electronegative atoms, which is oxygen. So I can say that the propanoic acid is more acidic than phenol. Okay, so propanoic acid lebih acidic daripada phenol. And then for the 2-chloropropanoic acid, gonna be the most acidic. Phenol gonna be least acidic. Okay, so this one gonna be the most acidic because of the presence of chlorine atom. Okay, at carbon number 2. So 2-chloropropanoic acid. So there will be a delocalization of negative charge in between the 2 oxygen atom. But with the presence of the electron withdrawing group, it will pull the electron density towards itself, and then this will stabilize the structure even more. Okay, stabilize even more, and then it's going to be the most acidic. Okay, so by understanding this, let us do the explanation here. So for the explanation, I can say that the 2-chloropropanoic acid going to be the most acidic, followed by propanoic acid, followed by phenol. This is because the phenol going to be the least acidic as the negative charge is delocalized into the benzene ring, which consists of carbon and carbon atom. Meanwhile, the propanoic acid is more acidic than phenol because the negative charge in carboxylic ion is delocalized between the electronegative oxygen atom. And the 2-chloropropanoic acid is more acidic than the propanoic acid as the presence of the chlorine atom act as an electron withdrawing group will stabilize the carboxylic ion even more. Hence, the 2-chloropropanoic acid going to be the most acidic amongst all of them. Okay. Now, we're going to do 9B where we have to show a two-step synthesis for the following carbon. So, kita akan tunjukkan 2 langkah sahaja untuk menghasilkan produk yang kita hendaki. So, starting from 1 bromobutane, we need to produce pentanoic acid. So, 1 bromobutane will have 1, 2, 3, 4 carbon, and then at carbon number 1, it's going to attach with bromine. And then we're going to produce a pentanoic acid. So 1, 2, 3, 4, and then 5. So 1 bromobutane will have 4 carbon, and then here we're going to have 5 carbon for the pentanoic acid. So we need to add up 1 carbon chain. So in order to add up 1 carbon chain, we have 2 options. We can use nitrile compound, or we can use Grignard reagent. So let us look into the cyanide compound first. Okay, so for the 1 bromobutane, we have the structure to be something like this, and then we need to change the Br into Cn in order to add up the carbon chain. So we need to use the reagent of NaCN in the presence of ethanol in the condition of reflux. So as a result, we're going to produce a nitrile compound here. And then this nitrile compound here can undergo hydrolysis using H2O and H+, and this will produce a carboxylic acid as a result of hydrolysis. Okay, and at this point you can also use H3O+ if you want. It is still accepted. And for this one, it is compulsory to write all of the condition here. If you are missing one, then you are losing 1 mark. Okay, so you need to write it completely for the reagent. Okay, now you might be wondering, sir, can I use Grignard reagent? Okay, now let us look into Grignard reagent. So let's say if you have 1 bromobutane, and then you're going to react that with magnesium in the presence of dry ether, what you're going to produce is MgBr here. Okay, so this is your Grignard reagent, and then in order to produce carboxylic acid, you need to undergo reaction with carbon dioxide followed by hydrolysis. Okay, so in this case, it basically involves two steps. This one is already considered one step, and then this one is two step, and this one is three step. So it's already three step, but we only need two step. So for this case, um, this pathway is not accepted because it involves three step. Okay, so if you were to do it one by one, you will get it to be 1, 2, 3, C double bond O, OMGBr. This is step number 1 using carbon dioxide. And then for step number 2, using H3O+, it's going to produce a pentanoic acid. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Sorry. And then 5 here. Then C double bond O, OMGBr. And then I will undergo hydrolysis again. Then only you get to the answer. So basically it involves 1, 2, 3 steps. So that is why the Grignard reagent pathway is not accepted. So for this case, only the nitrile compound will get the full marks. Okay. Now we're gonna do B2. So for B2, we have the butanoyl chloride from an alkene containing an 8 carbon. So we need to produce butanoyl chloride. So butanoyl chloride basically means that you're going to have 4 carbon. 1, 2, 3, 4. And then you're going to have C double bond O and then Cl here. Okay, so this is our product. 4 carbon. And then our reactant, we're going to have 8 carbon, which is an alkene. Okay, so for this case, I think the best way is to double the product. For example, we have 1, 2, 3, right? 1, 2, 3, 4, and then alkene, and then you will be also be doing 5, 6, 7, and 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to cleave the bond here using KMnO4 in H plus at high temperature so that we can get into carboxylic acid. So from the carboxylic acid, we can use PCl3 or PCl5 or SOCl2 in pyridine in order to produce our butanoyl chloride. Okay, so butanoyl chloride got 4 carbon and then it attached with chlorine. Okay, so the idea here we need to have 8 carbon at first. So we can draw it to be something like this as a straight chain alkene, and then we're gonna undergo oxidation using KMnO4 at high temperature at acidic condition. So what they're gonna do here is that we're gonna cleave the bond here, and then this is gonna produce an carboxylic acid. Okay, so you're gonna have 1, 2, 3, 4. So it's gonna be 1, 2, 3, 4, which is a butanoic acid. So the butanoic acid here can undergo reaction with PCl3. So the OH here gonna be replaced with Cl. Okay, and a butanoyl chloride gonna be formed. Okay, so this is the butanoyl chloride. Okay, so you're gonna involve 1 step and 2 step. Okay, so that's all for question number 9. For question 10, an amine which is C3H9 has three isomers which is V, W, and X. For question 10a, we have to draw the structural formula of V, W, and X. And for question 10b, we have to suggest a chemical test in order to distinguish between the isomers V, W, and X. And then we need to give observation and write the chemical equation involved. So for the isomers, you know that it will consist of primary, secondary, and tertiary amines, because in question 10b, they asked us to distinguish V, W, and X. So you know that it will consist of three classes of amine. Okay, so now by using the molecular formula of C3H9, we're going to draw the structural formula. Okay, so C3H9 is our amine here, and then they're going to have three isomers, V, W, and X. Okay, so you know that this amine going to have three carbon. So the first thing that we can do is we can draw their primary amines first, and it needs to be aliphatic because it only have three carbon. So 1, 2, and 3, 1, 2, 3, and then 1, 2, and 3, and then at carbon number 1 it's going to be attached with NH2. Okay, so here the number of carbon going to be 3, and then it's going to have 2 hydrogen, 4 hydrogen, 7 hydrogen, and then plus 2 here going to have 9 hydrogen, and then 1 nitrogen. Okay, so you know that the first structure going to be something like this, which is the propanamine. Okay, and then for the next isomer, which is W, this one is you know that it is a primary amine, and now in order to create a secondary amine, you can bring one of the methyl group and attach it with the nitrogen here. Okay, so it's going to look something like this. Okay, and the number of carbon is still maintained, which is 3 carbon, and then the number of hydrogen we have 4, 6, and 9. Okay, still maintained C3H9. So our structure going to look something like this. And then for X isomers, we're going to create a tertiary amine where we're going to bring this methyl group and attach it with the nitrogen here. So it's going to look something like this. Okay, so it's going to be attached with CH3, CH3, and CH3. Okay, so the isomers still maintain as C3, H9, and N. Okay, so our isomers X is going to look something like this. Okay, so these are the three isomers for V, W, and X. Now for question 10b, we have to suggest a chemical test in order to distinguish the primary, secondary, and the tertiary amine. Okay, and we need to see the observation and chemical equation involved. So in order to distinguish primary, secondary, and tertiary amine, what we can do is we can react that with Hinsberg reagent, which is Hinsberg test, or using the nitrous acid test. But for now, I'm using the nitrous acid test. Okay, so nitrous acid test will consist of the reagent of sodium nitrite and HCl that is produced in situ, and this need to happen at low temperature, which is at 0 to 5 degrees Celsius. Okay, so let's say if I have my primary amine here, which is V, and then I'm going to react it with sodium nitrite and HCl at low temperature, which is 0 to 5 degrees Celsius. So remember, this is compulsory. Without the 0 to 5 degrees Celsius, then your equation is wrong. So make sure you include this one. Okay, so what you're going to produce from the reaction of primary amine and sodium nitrite and HCl is the formation of diazonium ion. Okay, so the diazonium salt is unstable. So what you're going to do is they're going to remove the N2. Okay, so what they're going to produce is the formation of carboxylic ion as well as the nitrogen gas. Okay, so when there is a carboxylic ion, this carboxylic ion can react with a chloride ion. Okay, and this is going to produce haloalkane. So the product that we're going to get is nitrogen gas. and then we have the haloalkane. And then the other product that we can get is when the carboxylic ion react with water. Okay, so when the water attacks the carboxylic ion, what they're going to produce is alcohol. Okay, so the OH come from the water to enter here. So this is our third product. And then our fourth product going to be an alkene, because this is the carboxylic ion. So one of the hydrogen here can be deprotonated and makes a carbon-carbon double bond. Okay, so we will have 4 different options of product. Okay, and for the iazonium salt here, which is unstable, you don't have to write it because you can go straight away to the product, but I'm just telling you how we can get to the 4 different options of product here. Okay, so first we're going to produce the nitrogen gas, and then we have the haloalkane, we have alcohol, and lastly we have an alkene. Okay, now once we draw all the product, what we're going to do is we need to write the observation. Okay, so the observation that we can see from the reaction is that, okay, so this is your your reaction mixture. So at ice condition, which is 0 to 5 degrees Celsius, you know that a gas bubble gonna be forming due to the release of nitrogen gas. So your observation gonna be the bubble gas gonna release indicating nitrogen gas. So you need to mention bubble gas because bubble gas is what we see during the experiment. Do not just write nitrogen gas release. So if you write nitrogen gas release, your answer is wrong. Okay, because you cannot see the nitrogen gas. What you can see is the bubble gas that's coming out from the beaker, for example, and then it indicating nitrogen gas. Okay, so please be very careful with the wording. Now we're going to do the same reaction, but now using the secondary amine, which is W. So W, when we react that with the sodium nitrite with HCl at low temperature, which is 0 to 5 degrees Celsius, what we're going to produce is the nitrosamine. Okay, so you know that from the reaction of sodium nitrite and HCl, what we're going to produce is the nitrous acid. Okay, so basically HNO2 can also be written as HONO. Okay, sama maksud. So what's going to happen here is that the H and OH going to be removed out as water, and then the N and O can be joined together, and this going to create a yellow oil, or known as the nitrosamine molecule. Okay, nitrosamine, which allows the formation of the yellow oil. Okay, now for the next reaction, which is using a tertiary amine, which is X, we're going to react that with the same reagent, which is the sodium nitrite with HCl at low temperature. So what we're going to produce here is a trimethyl ammonium ion. So it's going to attach with H, and then the chloride ion going to come closer. So this structure here is very, very soluble. So when it is very soluble, what we're going to see is the clear solution. Okay, so this is how we're going to do their chemical test as well as mentioning the observation. So that's all for question 10. Now for question 11, the structural formula of tyrosine is shown below. So this is the structure here, and we need to write the chemical equation when the tyrosine react with the sodium hydroxide solution, HCl solution, and with methanol with the traces of the concentrated sulfuric acid. So for writing the chemical equation, we need to draw back the structure of the tyrosine, which is shown here. So the tyrosine here will have alpha carbon, where the alpha carbon going to be attached with the carboxyl group and also the amino group, and this is the side chain. Okay, so when the tyrosine react with the sodium hydroxide, so the sodium hydroxide here acting as a base. Okay, so base going to react with acid, datangnya daripada carboxylic acid, dan pada masa yang sama, the side chain here, as what you can see, will have the structure of phenol. So the phenol here is acidic. So the base gonna react with carboxylic acid, and at the same time the base will also react with the phenol. So it's gonna produce O minus Na plus, and here it's gonna produce COO minus Na plus. Okay, so we're gonna draw the structure again, and then here is the place where the reaction occur. COO minus Na plus and Na plus and O minus. So if you miss out this part, then you are wrong. So please be very careful and look into the side chain. Okay. And then for number 2, A2HCl. So we have our tyrosine, and then we're going to react that with our HCl, which is an acid. So the acid going to react with the base part, which is this part here. So what's going to happen here is that it's going to become NH3 plus, and then the chloride ion will come closer to the positive charge. Okay, so it's going to look something like this, which is NH3 plus and Cl minus. The other part, which is the acid and acid part, will just maintain as usual. And then for number 3, the tyrosine will react with the methanol. Okay, so the methanol gonna be having a formula of CH3OH, or you can put it as HOCH3. So in the presence of concentrated H2SO4 at high temperature, OH here gonna be removed, and the OH from the carboxyl group gonna be removed, and the hydrogen from the alcohol gonna be removed together in order to eliminate water. So the C double bond O and OCH3 gonna be combined together. Okay. At the same time, ester is formed. Okay. At the same time, this is an acid. So acid gonna react with the base here. So it will also gonna undergo NH3 plus, and then the HSO4 minus will come closer to the positive charge. Okay, so what you're gonna get is an ester bond here. Okay, so here is the ester bond, and then the amino group will also be protonated to be NH3 plus, and HSO4 minus going to be come close by. Okay, if you miss out HSO4 minus, it is still considered correct. Okay, because this one is not compulsory, but it is advisable for you to write it out. Okay. Now, for question 11b, we have to explain why tyrosine can react with acid and base. Okay, so in order to explain this, we can say that the tyrosine has alpha carbon. So the alpha carbon, it is attached with both of the amino group as well as the carboxyl group. At the same time, at the side chain here, it consists of the phenol, where it is also acidic. So the acid and base properties in one structure causes the tyrosine to have amphoteric properties, where it can react as an acid and it can also react as a base. Okay, so that's for question 11. For question 12, we have to draw the structural formula for the repeating unit when the monomers below undergo condensation reaction. So we have two monomers. We have 1,6-hexane diamine, and then we have the structure here, which is the acyl chloride. So in order to draw the polymer, it is advisable to draw the monomer once again. So this one is the structure here, and then we have another reaction using, sorry, this one should be Cl, and then this one should be Cl. Okay, so acyl chloride here. So what's going to happen here is that they're going to undergo condensation reaction, where the NH, okay, you can NH2, you can expand it to be NH and H. So HCl going to be removed as the byproduct, and one of the hydrogen will also be removed. Same goes to the Cl here. So what they're going to form is that it's going to forming an amide bond. Okay, so amide bond going to be forming here, which link the two monomers together in order to form a polymer, and the H plus at the side here going to be removed because it's going to connect with the next monomer. And the Cl here going to be removed in order to connect with the next monomer. So this linkage here is important. And then because it asks us to write the repeating unit, so we don't have to write N here. For polymer, you need to write the N. Okay, this one is for polymer. But for repeating unit, you don't have to write the N. So the N going to be removed. Okay. And now for 12p, we have to draw the structural formula of its monomer. So given here is the polymer. So we have to find the monomer. So we need to go reverse way. So as what you can see here, we have a double bond in the middle. So you know that we need to have a double bond on the side. Okay. So this is because when we undergo polymerization, addition polymerization, the radical gonna break apart. Okay, because this one carbon here refers to 2 electrons. So half-headed arrow refers to the transfer of 1 electron to the center and 1 electron in order to make another bond with the next monomer. Same goes to this side. So 2 electron, 1 electron gonna come to the middle, and then 1 electron gonna connect with another monomer. And this, as a result, will gonna produce a polymer to be something like this and to be something like this. Okay, so the monomer must have double bond here and double bond here, and then this one going to be a single bond. Okay, so this is how you're going to do the monomers. Okay, I think that's all for this video. Thank you so much for watching. Good luck for your exam and see you when I see you. Bye!